Write down an integral to determine the area of the region between the two graphs. The limits of the integration must be in exact form, and we're told that the graphs are y equals 9 minus x squared, so that will be the red one, and y equals the square root of 1 over the square root of 9 minus x squared, which would be the blue one. So what we want is the points of intersection. We need the x coordinates there. So I'm going to do this manually, but it's not a straightforward equation. So we've got, if we put them equal to each other, I'm going to try it on the CAS in a moment. I haven't actually done that, so I'm going to do that. So that would give me 9 minus x squared to the 3 over 2, if I just bring that up over here, is 1. Well, the only way that that can happen is for 9 minus x squared to be 1. So that means that x squared is 8, and therefore x would be plus or minus 2 root 2. So that gives me that. Let's just see if the calculator will actually solve that one. So we've got action, advanced, solve. 9 minus x squared is equal to 1 over the square root of 9 minus x squared, and close the bracket, and we're in standard. Let's see if it does it. Yep, so it did it. So that's okay. You could have done that on the calculator. And so your integral is going to be from negative 2 root 2 to 2 root 2, and then you can use a modulus. So we can have a modulus, and it doesn't then matter which way round we do it. So we could do 9 minus x squared, take away 1 over the square root of 9 minus x squared dx. Don't forget the closed modulus. So there's 4 marks there for that, and your calculator actually did part of it for you. So in the next part, it's just 1 mark. We just need to do that integral. So I'm going to go integral, and at the bottom there I'm going to have negative 2 root 2, and at the top I'll have 2 root 2, and then come down inside there, and we need the modulus, and I'm going to have 9 take away x squared, and I'm going to take away from that 1 over square root of 9 minus x squared, and that should do it. I don't think we need any brackets there, so we just need to tell it with respect to x, and nearest whole number, so we will probably want it in decimal. So we'll execute that, and it seems to be 33 to the nearest whole number. So now in part B, let's go down and look at part C, and we'll go down and look at that, and then we'll come back. So the region's going to be rotated around the y-axis, and we want to give an exact answer for this. Now, because of the symmetry, we're only really got to worry about rotating 1/2, and so we'll take this side. Now, what we need to do, if we're going around the y-axis, is we need to think about this. So it's going to be the blue curve from here downwards, and we know from sort of here, or anything else we've done, that actually the y-coordinate there is 1. So this one's going to be integrated from 0 to 1, and then the other one up to from 1 up to 9. And remember, our strip here is x and dy, so it's going to be pi x squared dy. So we are going to just add them together. So the volume is going to be pi times the integral of x squared dy from y equals 0 to y equals 1, and that one is for the blue curve, which is the square root. So, and then we're going to add to that pi times the integral from y equals 1 to y equals 9 of x squared dy, where that one is the other curve. So it's going to be pi times the integral from 0 to 1 of, and what is the blue one? So the blue one is y equals 1 over 9 minus x squared. So y squared is 1 over 9 minus x squared. So 9 minus x squared is going to be 1 over y squared. So x squared is going to be 9 take away 1 over y squared. So that is going to be 9 take away 1 over y squared dy. And then this one here, from 1 to 9. Now this time, sorry, let's go back. Yes, x squared we want. And so x squared would be 9 minus y. And of course we can do those on the calculator. So let's have a look at that. So the first one is going to be the integral from 0 up to 1 of 9 take away 1 over y squared. Oops, I need to close that bracket. And that's going to be dy. And for some reason that says negative infinity, which is not what I've ever got before for doing that one. So have I messed up somewhere? Let's have a quick look. So for the blue one, it's not a 0, is it? Not a 0. It is, sorry about all the messing around there. We've only got to integrate from the bottom of the curve there. That was really rather stupid of me. And where is the bottom of the curve? It is when x is 0. So that would be 1 over root 9, which is a third. I got that right in the solutions. Well, I should have probably looked at those while I was doing this. So that is actually 1/3 here. Silly mistake, but never mind, we've figured it out now. And so that is going to be 1/3. That's better, 4, that's what I got last time. So 4 pi, and then we also want to do the integral from 1 up to 9. And that one's just 9 take away y dy. I don't think we need a bracket on that. If I get a silly answer, I'll come back. Yep, it's 32 pi. And so that is 36 pi.